My name is Dr. P.C.Patel, retired research scientist and chief soil health specialist, Mati Agromart Private Limited, Anand, Gujarat, India. Today's topic is integrated farming system, Indo-Gangetic Plains. System, intensive crop husbandry involving rice and wheat, maize-mustard pulses, is indicated livestock, including dairy cattle and buffaloes. So type of farming system, crop livestock farming system. So here crop and animals. So we have to grow the fodder crops to feed the animals. And Punjab, Haryana, UP are the bowl of the rice and wheat production. So you can see here crop and livestock indicated farming system. So here livestock production. So livestock production supply the dung and urine. So nutrient cyclics it add in soil, so soil fertility has been improved. They grow the forage crops, particularly they grow the berseem, then sorghum, oats for the growing, for the feeding to the animals. Also, they feed the crop residue, rice and wheat to the animals, cows and buffalo, but mostly they keep more cows. Here you can see the crop residue burning and environment pollution. So here you can see that Punjab, Haryana, Uttar Pradesh, Bihar, West Bengal, and total. So the red color show the rice residue, blue color wheat, and green color show the total. And how much only recyclable, that in the star. So you can see here the total out of 3, you can find the rice here in Punjab more, Uttar Pradesh is also more, Bihar is also, and West Bengal. So you can see the total rice crop residue. Then wheat is greater in Uttar Pradesh, followed by Punjab and Bihar. So you can see the total crop residue of rice wheat. So you can see the maximum. So rice and wheat crop residue produce and quantity of total residue available for agriculture rice cycling in different rice producing states of northern western Indo-Gangetic Plains. So today we will talk about the Indo-Gangetic Plain. So you can see here they buried the rice crop residue and it created pollution, air pollution. So health of the irrigated rice and wheat system have resulted in production of huge quantity of crop residue. We have shown rice and wheat. Burning of rice straw is common in northwestern parts of India, causing nutrient losses and serious air quality problem affecting human health and safety. So we are observing the air pollution in Delhi. So rice wheat cropping system of the Indo-Gangetic Plain has played a significant role in the food security of India. So they are the bowl of the rice and wheat and supply the food to the other states. However, sustainability of this important cropping system is at risk due to deterioration of soil health, mounting pressure on natural resources, and emerging challenges of climate change. So there are three problems: deterioration of soil health. Why the soil health is deteriorated? Because they are growing continuously cereal crop, rice and wheat throughout the year. So obviously, both the crops require the more nutrient. So the soil has been, in the soil you will find the multi-nutrient deficiency. You can find the zinc deficiency, iron deficiency, nitrogen, phosphorus, and so on. Then there is a depletion of the natural resources like irrigation water, and the soil becomes the saline soil due to indiscriminate use of the irrigation water and chemical fertilizers. The soil health is deteriorated, and we are observing that due to global warming, the climate changes, there will be the problem in the crop productivity of the rice and wheat. So conservation agriculture involving minimum tillage means zero tillage, and innovation in crop residue management to avoid straw burning should assist in achieving sustainable productivity and allow farmers to reduce nutrient and water inputs and reduce risk due to climate change. You know that when we are applying the indiscriminate use of chemical fertilizer pesticide, then it will create the air pollution, global warming. So it is Indo-Gangetic Plains conservation agriculture, the key to food security. So resource conservation technology produce high wheat yield while reducing farmer cost by 20%. A shift to conservation agriculture in rice would create positive synergies in the production of other crops in rotation. So they are follow the crop rotation also. In Northwest India, zero-tillage seed drills were the most common item of agriculture machinery after tractor. So you know that minimum tillage or zero-tillage is the beneficial for the improving the soil fertility. Frequent cultivation or tillage operation is harmful and it deteriorates the soil structures. And also, when there is a continuous cultivation, then there will be exposure of the soil to the sunlight, and the population of the microorganism has also been declined. So it is a research paper, the rice feed system in the Northwest Indo-Gangetic Plains of South Asia, issues and technological intervention for increasing productivity and sustainability, paddy and water environment. It is published in 2021 recently. The conventional tillage can favor the germination of grassy weeds in wheat. When you are continuously tillage operation, then there will be favor of the grassy weeds in wheat crops. Zero tillage with mulch load conserve 4% higher moisture due to 2.3% lesser soil temperature. Evaporated 27.6 lesser than the conventional tillage. So it is beneficial in zero tillage. Delayed rice transplanting with short duration variety has potential of saving of up to 140 mm of irrigation water in semi-arid area of Northwest Indo-Gangetic Plains. So if the farmers are sowing the delayed rice, but early maturing variety, short duration variety, then they can save up to 140 mm of irrigation water in semi-arid in such area. So zero tillage is proven technology for sustainable wheat intensification in the Eastern Indo-Gangetic Plain. You can see here. Zero tillage is a proven technology for enhancing wheat productivity, enhance food security in the Indo-Gangetic Plain while reducing production cost. You know that when we cultivate the land frequently, then it requires the energy. So for that, we require diesel. So when we are doing the minimum tillage or zero tillage, then there will be reduction in the cost of the cultivation. A win-win scenario that should support rapid technologies scaling, even though adoption remain modest to date. So many farmers have been started zero tillage and conservation technology. So you can see here the tractor drawn seed drill. Another resource conserving technology introduced to Indo-Gangetic Plains is lesser assisted land leveling. Here, you can see it is a lesser assisted land leveling. So many fields have uneven surfaces. You know that the topography of the land is uneven, and when we are applying the irrigation, then wastage of water. So which lead to wasted water, suboptimal germination, and lower yield. So it is proved that in uneven surface land, we are getting the low crop productivity as compared to the level surfaces. So we can minimize the water and better germination of the seeds, so less requirement of the seeds, and we are getting the higher crop productivity in level surfaces. Then mulch is a good option for rice residue management during the wheat crops, especially with no tillage. So mulch can increase yield, water use efficiency, and profitability while decreasing weed pressure. So when you are using the mulch, rice mulch, then there will be benefit of the increasing the crop yield, then water use efficiency, their evaporation rate is decreasing. So we have to apply lesser irrigation and we are getting the more profitable. And also there is a less weed pressure. So the cost of the labor removing is also we can save. So we are getting more profit per unit area and time. Then backyard biochar pyramid cleaning. You can prepare the biochar on small scale in a pyramid plane. So you can prepare the biochar from the rice straw. Here, biochar produced from rice straw. Here you can see that they are prepared. The biochar from the rice straw is one way to keep carbon sequestration sustainable. Biochar is able to improve soil fertility and on crop yield, reduce greenhouse gases emission, and increase soil carbon storage. So it is a good thing. You can see here the farmers are applying the biochar in a rice field, and definitely we can increase the crop productivity of the rice and wheat and so on. Here, when we use the biochar, then there will require lesser chemical fertilizers, and biochar is organic farming. So prepare surplus residue for producing biochar and co-production of bioenergy, for using a soil amendment to improve soil health, increase nutrient use efficiency, and minimize air pollution. I have prepared the biochar from the corn store and cluster bin store, and we found that the corn crop productivity has been increased in the presence of the chemical fertilizers along with the biochar. So we can increase the nutrient use efficiency. When we apply the biochar in soil, then it retention of the nutrient, and nutrient has been not leached down. So we can reduce the air and water pollution. So conclusion, crop residue incorporation improve physical, chemical, and biological properties of soil. In long term, incorporation of crop residue increase the productivity. Overall, incorporation of crop residue appears to be a better management option. Incorporation should be done at least 10 days and preferably 30 days before the establishment of succeeding crop. So thank you, Lord, for giving to me. So here you can see the rice bowl. Thank you very much.